Wondered how data moves seamlessly across the internet? Network protocols are the unsung heroes ensuring smooth and reliable communication between devices. In this video, we dive into the essential protocols that form the backbone of modern networks, from TCP UDP to specialized protocols like RIP and OSPF. Learn how these protocols work and their importance in everyday networking. Now, let's look at what network protocols are. They tell devices how to talk, when to talk, and what the messages mean. They define how data is formatted, how it is sent, how it is received, and how errors are handled. Without protocols, computers would send random signals that no other device could understand. Now, let's look at common network protocols. 1. HTTP HTTPS. HTTP, Hypertext Transfer Protocol, is the protocol used by web browsers and servers to send and receive web pages. HTTP is the foundation of the World Wide Web. When you open a website, your browser uses HTTP to request a page and receive content, HTML, images, videos, APIs. How HTTP works. You type a website URL. Browser sends an HTTP request to the server. Server processes the request. Server sends an HTTP response. Browser displays the content. This works on a request-response model. Example of HTTP status codes include 404 not found, 400 bad request, and 500 server error. HTTPS, Hypertext Transfer Protocol Secure, is HTTP with encryption. HTTPS uses TLS or SSL to encrypt data, prevent eavesdropping, ensure data integrity, authenticate websites. HTTPS protects users from attackers on public Wi-Fi and the internet. Without HTTPS, passwords can be stolen, data can be modified in transit. Users can be tracked or impersonated. 2. TCP UDP, Transmission Control Protocol or Internet Protocol, is the core communication model of the Internet. It defines how data is packaged, addressed, sent, routed, and received between devices across networks. Without TCP UDP, the Internet would not work. How TCP UDP works. Data is created by an application. TCP UDP breaks it into packets. IP adds source and destination addresses. Data is sent over the network, and receiver reassembles the data. 3. UDP, User Datagram Protocol, is a transport layer protocol used to send data quickly over a network without checking if it arrives safely. UDP focuses on speed, not reliability. Key characteristics of UDP. 1. Connectionless, no handshake before sending data. 2. Fast, no waiting for acknowledgements. 3. No guarantee, packets may be lost, duplicated, or arrive out of order. 4. Low overhead, minimal protocol data. 5. Stateless, no session tracking. Key differences between UDP and TCP. 1. Speed, UDP is faster than TCP. 2. Connection, TCP set up connection between the sender and the receiver before transmitting, but UDP doesn't. 3. Reliability, TCP is reliable while UDP is not. TCP ensures packets are delivered successfully, but UDP doesn't. Next, IP, Internet Protocol. Internet Protocol handles the addressing of every packet and routing the packet to its destination. It asserts the sender's address and the corresponding receiver's address on the packet and route it to the receiver. It does not guarantee delivery. That's the job of TCP, Transmission Control Protocol. 2 types of IP, IPv4 and IPv6. Example of IPv4, 192.168.1.1. This is what many computers are currently using for communication. An IPv6, which is longer and has more address blocks, will take over from IPv4 in the future when IPv4 will be fully exhausted. Next protocol, DNS, Domain Name Server, converts domain name into IP address. For example, it converts youtube.com to 142.250.190.14. How it works. The user types the domain to search on the browser, example, www.youtube.com. This is supposed to open YouTube page, but the browser needs the YouTube IP address, not the domain name. Every registered domain has a corresponding IP address registered with. This is to make internet human-friendly. Browsers use IP addresses to search the internet, but humans cannot memorize IP address. Rather, we easily memorize domains such as ebay.com, etc. So, the user's browser sends the domain to the DNS requesting for the IP address. The DNS receives the domain, checks its record and returns the IP address registered to the domain. The user's browser uses the IP to search and gets to the destination. These actions happen in microseconds as you watch your browser rolling before a web page opens. So, DNS is like a phone book that stores all registered domain names with their corresponding IP address. Don't forget to like, share, subscribe, and hit the notification bell to receive more tips in networking, cybersecurity, and AI. Next, FTP, File Transfer Protocol. FTP is a standard network protocol used to transfer files between a client and a server over a network. It can be used to upload or download files from the server. It uses default port 20 for active data mode and 21 for control or command. How it works: 1. Client connects to the FTP server to upload or download files. 2. User authenticates by entering username and password. This is to ensure data security. 3. Files are uploaded or downloaded from the server. There are certain security issues using FTP. 1. Data is sent in plain text. 2. Usernames, passwords, and files can be sniffed by attackers. Why it is risky: 1. It is vulnerable to man-in-the-middle attacks. 2. It is not suitable for sensitive data transfer as data is usually in plain text. Next, SFTP, Secure File Transfer Protocol. SFTP is a secured version of FTP. It creates a way for secure transfer of files over a network. It is commonly used in cybersecurity, networking, and system administration. It runs on top of SSH, Secure Shell, which means 1. All data is encrypted. 2. Authentication is secured. 3. It protects against eavesdropping and man-in-the-middle attacks. How it works: 1. It uses TCP port 22, same as SSH. 2. It establishes an encrypted SSH. 3. It transfers files securely through the tunnel. SFTP is like sending files inside an encrypted tunnel, so even hackers sniffing the network with their sophisticated tool would see only gibberish and not the real data being sent. Now you know how the internet really works. From HTTP and HTTPS to TCP IP, UDP, and DNS running silently in the background every second you're online. But this is just the foundation. Don't forget to like, share, subscribe, and hit the notification bell, because in my next videos, we'll break down how hackers exploit these protocols, how firewalls and VPNs protect them, and how you can use this knowledge to start a career in networking and cybersecurity. Please leave your comments in the comments section. Also, let me know which area you would like me to demonstrate in my next live streaming. Bye for now.